Welcome everybody. In this next video, I just want to summarize all the exponent rules we've talked about. We've kind of talked about them mainly individually, which doing a couple examples that are a little bit more complicated. So now I just want to summarize them and look at some examples that require multiple steps. So I'm going to call this Properties of Exponents a summary for our title. So in here, I'm just going to really kind of rewrite all of our exponent rules. Now, this could be a good thing for you to put on maybe an index card or even just kind of maybe copy this page of paper from your notes and kind of leave it with you as you're doing homework and things. That way you have it right in front of you. It doesn't hurt to also put in some examples on your note cards or your summary sheets so that you can follow along a little bit easier too. So in each case, we're going to say if m and n are integers, and a, b, and c are real numbers, we have the following. Now, I will say as well, we're talking about m and n being integers for our exponents, but they actually don't even have to be. These rules still work with fraction exponents and decimal exponents and things like that too, which is really, I think, pretty interesting. One little kind of fun side note is that a fractional exponent actually relates to a root. So even though we're not going to go really in depth there, in our class, we'll see that in other classes. So when you have fractional exponents, it's actually a different way for us to work with things like square roots and cube roots that can be pretty helpful. All right, so our first one is the product rule. So it says that when we multiply two things with the same base, we add the exponent. And maybe we'll do our examples in purple. So something like x squared times x cubed would be x to the 2 plus 3, which is x to the 5th. Now, when I write my definitions, I personally do like to put in words what things mean. I find it easier. So if I look at something like this back in my notes, I may not have any idea what it was saying, right? If it's been a couple of weeks, maybe I'm preparing for an exam or a final or whatever it is, I may have forgotten what this means, right? Or maybe I'm just not good at reading symbols in math. So I think it does help to write in words what you're supposed to do there or what the rule was for. And then also to give it just a short example. Again, if I see something like this and I'm like, oh, I add them, right, that hopefully will jog my memory. So that was the first rule that we looked at. We also looked at power rule. So this one here is a little bit different. So notice that we have a double exponent with only one base. So you're going to multiply your exponents there. It doesn't really have an official name of a double exponent. I'm just gonna call it a double exponent. It's easy to understand. So for example, something like x squared to the 3rd power is x to the 2 times 3, which is x to the 6th power. And then for me too, I also tend to like to circle those. I don't know why. It just helps me kind of visually see that double power and to remember to multiply it. So the power of the product rule basically says that if you're multiplying and you have an exponent on the outside, you can distribute that exponent inside. And it actually is the same thing for the power of a quotient rule. You do want to make sure that b is not 0 there, obviously, so you're not dividing by 0. But we're basically saying that you can really just distribute that power inside here. So we can distribute exponents when multiplying and dividing. I will say this does not work if you have adding and subtracting. So if you need to make that little note for yourself, you can go ahead and add that in. So just remember that it does work for multiplying and dividing, but if you have a plus or a minus sign inside, not a negative, but a plus or a minus in between two variables or two terms, then you cannot distribute. So that's just want to make that really clear here. So for example, let's say I have 2x to the third power. That would be 2 to the third power times x to the third power. So 2 to the third power is 8. This would be 8x cubed. Or for example, let's say I have something like x squared over y to the fifth power. Again, I can go ahead and distribute that in. So I have x squared to the fifth over y to the fifth. And then within here too, I can also apply that other rule and multiply those. We are done. I can't subtract these or anything because I have different bases. So if I have different bases, I do have to stop here. So there's the 10. There's my example. All right, we're on number 5. Okay, we also have the quotient rule. This is the one where you have the same bases and you're dividing and you subtract your exponents. And again, we just have to make sure that a is not 0, so we're not dividing by 0 here. So when dividing, with the same base, we can just subtract the exponents. Star. So something like x to the fourth y cubed over x squared y. So I can line up my same bases. So I'm just going to use a couple different colors here just to show you. And don't forget there is always a 1 there. So this would be x to the 4 minus 2, y to the 3 minus 1. So I have x squared and y squared. Now again, if you want to make yourself a note to always subtract top to bottom, just to remind yourself if you think you're going to make that mistake, go ahead and do that. So you can always add in extra notes here if you feel like you need to remember something else. Zero exponent says a to the 0 is equal to 1. So anything to the 0 power is 1. For example, something like 3 to the 0 equals 1. X to the 0 equals 1. Maybe I want to put an extra example in here and do something like, well, what if I have 3x to the 0, right? So then this part is 1, but my answer is 3. So maybe I need to put a little extra example there to remind myself to be careful, right? Only things that have the 0 power is 1. But everything else, if it doesn't have that 0 power, you may have to still work with it. And then the last rule we saw was that negative exponent. So if you have a negative exponent, you are just going to take the reciprocal or flip. So if the negative exponent occurs in the numerator, you bring it to the denominator. If it occurs in the denominator, you bring it to the numerator. So here, you may just want to write the word flip or find the reciprocal or something like that. And also, once you do flip, that exponent becomes positive. Again, if you need to make that extra note for yourself, go ahead and write that in. So once we flip, the exponent becomes positive. So something like 2 to the negative 3 is 1 over 2 to the third power. And then if I can simplify, I would. So 2 times 2 times 2 is 8. Or maybe I have something like x to the negative 4 over y to the negative 5. So this one is going to flip this way, but this one is going to flip this way. So I end up with y to the 5th over x to the 4th. So those are the main rules that we have talked about in a couple videos now. And to wrap up, I just want to do a few examples that are more multi-step. So you'll see where that applying these rules kind of all together. So that's why I said it's a good idea to maybe have these rules on one sheet of paper or a note card or something like that, so you can just kind of easily refer to it if you're getting stuck. So what about something like x to the negative 3 times x to the 7th times x to the negative 10? So first of all, again, for me, I like to leave my negatives to the end. I don't like to start flipping things around to the last step on a personal note, but you're welcome to flip these first if you want to. So you're going to notice that with the exponent rules, typically you can start wherever you want. So always just ask yourself, what's one thing I can do here, and do that one thing. And then ask yourself, okay, what's another thing I can do here? So for me, I see that I'm multiplying everything together and I have all the same base. So this reminds me of the product rule, which means that I can take those exponents and I can add them up. Now, I don't want you to focus so much on memorizing every single name or rule, although it is helpful as you're kind of going through and watching the videos, but it's really more important to know how to work with them, right? So here, I'm just going to make a little note that this is a product rule. So if you're following along at home and you kind of are reviewing the notes later, you're like, hey, what did I do there? Then you can refer to your notes and say, oh yeah, I used the product rule, I added my exponents. But normally you don't have to write that rule out as you're doing your work. So here, let's see, I have negative 3 plus 7 is positive 4 plus negative 10 is negative 6. So I have x to the negative 6. And now I look at it again, I say, okay, is there anything else I can do? And there is. So what I can do here is I can go ahead and flip, right? Because I see a negative exponent. So I'm going to go ahead and flip. I always want to clear out those negative exponents. So I have 1 over x to the 6th. Here's another example, again, kicking it up a little bit here. So I'm noticing again that I'm multiplying two things together. So when we're multiplying, again, we're still using that product rule. So here, let's see, my numbers out front, those are not exponents. Those are not the same base. They're just regular multiplication, 4 times 5. So to start, you don't have to do this step if you don't find it helpful. But sometimes it does help to just, when you're multiplying, to rearrange things. And the reason I can do that is because, remember, multiplication is commutative. So you can't just rearrange anything you want, but I can here because it's all multiplication. So now 4 times 5 is 20. Here I have the same base, so I can add those exponents. And same thing here. Well, 2 plus 6 is 8. And then 5 plus negative 8 is negative 3. So now I'm going to look at it again. Again, I do see I have a negative exponent here, so this part is going to have to flip down. And I get my answer of 20 m to the 8th over n to the 3rd. If I look again, I don't see anything else I can do, right? I have no more negative exponents. I have different bases now or different variables, so I can't actually go any further. All right, so a lot going on in this one. And again, I want you to think about what's one thing I know how to do here, or what's jumping out at me that there's something I can do. So the thing that jumped out at me first is inside the parentheses, I see a lot of matching, right? I see my x's match, I see my y's match, which makes me think quotient rule. So I'm going to kind of match up my x's and my y's here and my numbers. Now this is just a regular division in this first case, right? Because they're not bases, they're not exponents. So what I see here, 8 divided by 2 is going to be 4. And then for these guys, I'm going to use that quotient rule, which says that I can subtract my exponents. So I see 2 minus 8, and then I see y to the 5 minus 1, because there would be a 1 there. I'm going to just leave that little square on the outside for now. I'm not even going to worry about it. I'm going to keep simplifying. So I have 4x. Now 2 minus 8 is negative 6, and 5 minus 1 is 4. And now I'm going to look again and say, okay, what else do I know how to do? And I say, okay, I have all multiplication. I can distribute that exponent in. So this here is that power of a product rule. Really, I mean, just a power rule, right? So you're kind of distributing that power in. But specifically, it's power of a product because we're multiplying. So this becomes 4 squared, x to the negative 6 squared, y to the 4 squared. And then here, I'm going to go ahead and multiply. So that's that power rule. 4 squared is 16. Here, negative 6, that's a negative, times 2 is negative 12. 4 times 2 is 8. And then again, I look again and I say, okay, hey, I can go ahead and I can flip this down. And I only flip the ones that have negatives. So these definitely get quite complicated quickly, right? If you start adding exponents and division or multiplication, it can get pretty tricky pretty fast here. But you just want to take it one little step at a time. And like I said, the nice thing with these is that the majority of the time you can do it in any order that you want. I say majority because I can't think of an example where the order would really change, but I want to make sure there could be an exception somewhere that I just haven't thought of. But in general, you can usually just see whatever you see, just start there. So here I decided, okay, I can do some stuff inside the parentheses here. I see this division. I know I want to subtract those exponents. So I just started with that. And then I looked again. I said, okay, well, what else can I do? And I saw this little square. And I'm like, okay, I remember bringing that in. So now I distributed there. So I just took it one little step at a time. And you want to make sure you ask yourself, what's one thing I can do? Not what's the final answer. That's too much, right? To look at this and just get the final answer. I can't get the whole thing in my head. It would take me, I mean, I guess I could, but it would take me just as long because there's so much computation there. It's just as easy to write it out, just as quick to do those one step at a time. So again, the big thing here is just to really just do one step at a time. Okay. Don't overthink these. Don't rush them. Just take your time with them. And then at the end, of course, just double check, okay, is there anything else I can do? And if you don't see anything else, then you're probably all set.